Alright, hello everyone. Mr. Knight here. Alright, so I've got your, this week we missed class, and so we missed class where I would discuss application services. So I'm going to do that now. But before I get into that, I was going to show you something else here. Let's, we're going to go to module. Actually, we want to go to test out, actually. So use your modules to get yourself to test out. And I want you to see, matter of fact, I'll bring this back up here. All right, notice here in the latter part of the schedule here, it's due on 12/7, which is taking practice exams. But that's just when it's due. It doesn't mean that you shouldn't be working on it. So I want to show you something ahead of taking the cert exam, which I'll be sending you guys a voucher on it the next couple of weeks. So you can go ahead and get that planned out, or you can decide you want to take the final exam instead. So I'll force you guys into a decision on that soon. But what I want to show you here is the practice exams. And I think I went over this a little bit before, but maybe not. So prepare, so here at this B.0 here, prepare for the exam. So underneath here, you've got several exams that you can take, and they're starting right here. Here's some information that you should probably go through. Matter of fact, I may make a video for you on this and go through some of this, just kind of preparing you for the exam. But right here is just different sub-exams, I guess, sub-practice exams. You know, B21, B22, B23, B24, B25, B26. B27 is the actual practice test. I want you to notice it's 90 questions, takes you an hour and 30 minutes. So you may, and then keep in mind, you have to take all of these eventually anyway, and you can take them as many times as you want. But I would go ahead and start working on some of these and just see how you're doing with your learning. This kind of will assess how you're picking up the material at this point. This is early enough, here being what, mid-October, so you've got a couple of months ahead of the end of the semester when you want to plan to take the cert exam. Go ahead and start taking these tests. You may even feel bold enough to jump in and take this practice test here. It doesn't count against you. I mean, I'm going to use the highest score on it, so there's no reason not to do it more than one time. So my advice to you is start taking these practice tests. Do it early and often. So in addition to whatever homework you're doing, try to squeeze some of this into your week so that it doesn't all come on to you as a giant burden at the end of the semester. All right, that's the tip I'm giving you. I suggest you take it. If you don't, there's no upside to not taking that advice, right? So, all right, otherwise we're going to shift gears here, and I'm going to I also want to point out this Last Mile scholarship here. You need to, there's no reason not to go ahead and apply for this if you're interested. You can go to this website right here, lastmile-ed.org, Microsoft, or you can scan this with your phone. It does ask, it's a little bit of an application process, but you're going to get $500, free mentorship from the GMI, and free LinkedIn Premium. That's and GitHub benefits. So free LinkedIn Premium is pretty cool. That's paying for LinkedIn Premium is like $50 a month. So the worst thing that can happen by applying for this is you don't get it. You already don't have it, so there's no downside, right? Okay. All right, with that in mind, I'm going to shift gears here. I'm going to do the presentation for the week. Try to keep it brief, but there's a lot of material, so it might not be as brief as you want. So just, grab a beverage, sit back, and let's watch this. All right, so we're going to be explaining application services, and that'll be clear to you what that means here momentarily. So there's our objectives here. We're going to talk about time synchronization and the role of NTP. We're going to explain the use of web file print and database services, email and voice services, and also talk about high availability services and how we use redundancy and load balancing. Right, summed up like that doesn't sound like a lot, but in order to accomplish these things, there's a lot of details. So let's jump into it. So with the application security and time synchronization, we are covering these two Network+ objectives, exam objective 1.4 and 3.4. All right, so we're going to go over these items here: TLS, NTP, and PTP. All right, so the TLS, right? So many TCP/IP application protocols were originally designed without built-in security, leaving them open to spoofing, eavesdropping, and data tampering. Transport layer security, or TLS, was developed by the IETF. I would make a note of that, IETF, and I would look it up so you know what it is. To add authentication and encryption to these protocols, TLS operates between the application and transport layers. So we know between application and transport, that would be your transport layer 4 or application layer 7. And then session or presentation in the OSI terms. So it's between those two. So to secure communications and manage encryption. So that's what TLS is all about. When used with HTTP, it becomes HTTPS. But TLS can also secure other protocols like DNS, NTP, FTP, POP3 or IMAP, SMTP, and LDAP. So it can be used in conjunction with older insecure protocols to, in fact, make them secure. A variant of TLS is called DTLS. It provides similar protections for UDP-based communications, such as in VPNs. TLS uses digital certificates issued by a trusted certificate authority, or you will hear it called a CA sometimes, like you see here on the screen, to verify server and sometimes client identities. During the TLS handshake, the client and server exchange certificates and establish an encrypted tunnel using a public-private key pairs. Only the server holds the private key, preventing outsiders from decrypting or altering traffic. Modern TLS versions support perfect forward secrecy, or PFS, ensuring that even if a private key is later compromised, past sessions remain secure. The most current version of TLS is 1.3, and servers usually restrict connections to TLS 1.3 or 1.2 with mutually supported cipher suites for security. TLF itself was developed from an older protocol called Secure Sockets Layer, or SSL. SSL is now obsolete. Some good bit of information there about TLS. You should feel sort of ramped up on that after going through the learning and after this review. Matter of fact, just to make you guys aware, and I'll show you at the end of the presentation here, but I uploaded these slides to the Module 7 section, and they have my instructor notes in the slides that aren't on the original slide. So you wanted the notes in which I'm speaking from, then they are built into the slides. All right, Network Time Protocol, or NTP. I always been kind of fascinated by this particular protocol. So many network-based applications such as authentication, logging, scheduling, backups, whatever, depend on accurate time synchronization. The Network Time Protocol, or NTP, is used to synchronize time across devices on a network. NTP operates using UDP port 123. That seemed appropriate, right? Time Protocol 123. It uses that for communication. So you've got Stratum 1 and Stratum 2 NTP servers. Stratum 1 connect directly to precise time source like atomic clocks. You see in our diagram here, atomic clock at the top, right? Stratum 2 obtain their time from Stratum 1 servers over the network. So they're one removed from the atomic clock, theoretically making them less precise. So each stratum level represents one additional network hop away from the original time source. Lower stratum level servers can act as clients to higher ones and servers to lower level devices. Routers, switches, directory services can be configured to serve as local NTP servers. In an environment in which I worked in for a good part of my career, we had a single router for years that was the NTP server for the entire organization. We built it into a high availability, redundant pair over time because it became more and more critical and more things depended on it. But for a long time, it was just a simple old school Cisco 2600 router that was just on the network just to serve NTP. We kind of cared and fed for that thing like it was a little baby, so it was kind of neat. All right, so best practice is to configure each device with at least 3 reference time sources for redundancy. So at least 3. All right, there's a protocol Simple NTP, or SNTP. It's a lightweight version used by clients that cannot provide time to others. So if it's only a client, there's no reason, then it doesn't have to run NTP. In Windows, time synchronization is managed with the W32TM command. In Linux, NTP is configured through the /etc/ntp.conf or config file. NTP handles time drift using 2 correction methods. The slew method, which gradually adjusts time in small increments, or the slam method, which instantly resets the clock when the drift is large. The slam method can be a bit risky, but it can also be an immediate correction. So incorrect time settings can cause authentication failures or invalid token errors when accessing services. When a local Stratum 1 server is unavailable, public NTP pools like time.google.com and time.windows.com can be used to secure the time. Secure time synchronization, network time security uses TLS over TCP 4460 and sometimes 3443 or 4443. So let me say that again. NTS, or Network Time Security, uses TLS over TCP port 4460 and sometimes 3443 or 4443. So just wanted that to be clear. It's a lot of numbers there. All right, we got our precision time protocol. PTP is designed for systems that require extremely precise time synchronization beyond what NTP can provide. PTP is defined by the IEEE 1588 standard and supports nanosecond level accuracy. It's used in industries such as 5G communications, industrial automation, medical technology, financial trading, and broadcasting. Where NTP provides millisecond provision, PTP achieves nanosecond precision. PTP can act as a more accurate replacement for NTP in time-sensitive applications. It operates primarily at layer 2 of the OSI model for maximum precision. PTP-capable network adapters and switches contain hardware clocks that improve synchronization accuracy. The protocol includes mechanisms to measure and correct network delay, ensuring precise timing. Within a PTP domain, the grandmaster clock, as you see listed here on the screen, serves as the ultimate authority for time distribution. A boundary clock, the next bullet there, connects multiple PTP segments, synchronizing with the grandmaster and distributing time further. An ordinary clock has only one PTP interface and typically acts as a time receiver. When two PTP clocks communicate, one acts as the time transmitter and the other as the time receiver. Grandmaster clocks always serve as transmitters, while boundary clocks can serve as either receiver, or probably better to say both receiver and a transmitter. Then transparent clocks, which you don't see listed here but an additional note, enhance accuracy by measuring network delay and adjusting timing messages accordingly. PTP can also function as a layer 3 protocol over IP, but this method is less accurate than layer 2 implementation with hardware stamping. So yeah, it's noteworthy that this performs at its most efficient and is intended to perform at layer 2, but is capable of doing layer 3 over IP if that's the way you need to do it. All right, moving on to 7.2 here, lesson, web file, print, and database servers. Covering these two exam objectives here for Network+, 1.2 and 1.4. All right, let's jump in without further hesitation. All right, so we've got the various, we're going to go a little depth into each one of these items here. Our HTTP, HTTPS, FTP, SFTP, SMB, and NAS, and then database services. All right, so HTTP, TCP port 80. Websites and web applications are among the most common and versatile network services today. Modern web technology goes far beyond static pages, supporting dynamic, interactive, and database-driven content. The core of web communications is the Hypertext Transfer Protocol, or your HTTP. HTTP allows clients, usually web browsers, to request resources from servers using TCP port 80 by default. Client request specifies resources using a uniform resource locator or a URL. The HTTP header defines how requests and responses are formatted, while the payload contains the actual content. Most payloads are HTML pages, which browsers interpret and render the text, images, and multimedia. The POST method, POST, allows client to send data to servers such as form submissions. So that would be, if the website, it needs to gather data from the user. HTTP is generally stateless, meaning servers don't retain client information between requests. To maintain sessions, servers use cookie scripts and databases, which improve interactivity, but also increase vulnerabilities. I mean, you guys are aware of the inherent risk in cookies. Hosting a website requires an HTTP server connected to the internet. Organizations can host their sites using dedicated servers or virtual private servers, a VPS, cloud hosting, or shared hosting. Dedicated servers offer full control but higher cost, while shared hosting is cheaper but less reliable. Cloud hosting allows scalability by distributing resources across multiple physical machines. The most common web server platforms are Apache, Microsoft CIS, and NGINX. All right, that brings us to our HTTP secure, or HTTPS. Notice our image here. We'll speak to that in a second, but basically it gives us our HTTPS padlock icon. So, plain text HTTP transmits data without encryption, making it vulnerable to attacks. Unsecured HTTP connections can be intercepted or altered by malicious actors. Modern web browsers now warn users before connecting to unencrypted HTTP sites. Some browsers may block HTTP connections entirely for safety reasons. You don't find many unsecured websites now. Most websites you visit, I mean, I would hesitate to give a percentage, but it would be really high, are HTTPS sites. But, okay, secure communications, HTTP is combined with TLS, or Transport Layer Security, which I explained a little earlier. The secure version is known as HTTPS or HTTP Secure. HTTPS provides encryption, integrity, and authentication between client and server. All right, encryption and authentication seem to be easily definable. You probably translated that in your brain and understand what those mean. Integrity just simply means you are receiving what you expected to receive, right? When you're on a website, you are on the website that you intend to be on, and is providing you the service or content that you expected. A compromised website, that's one of the things, is to compromise the integrity. So HTTPS traffic uses TCP port 443, as you see outlined on the slide here, while unencrypted HTTP uses port 80, which we just discussed. When a secure session is established, the website URL begins with https:// padlock icon appears in the browser's address bar for HTTPS sites, like you see that represented here. Clicking the padlock reveals details about the site's digital certificate. This certificate identifies the website and proves it is trusted by a certificate authority, or a CA. The CA verifies the organization's legitimacy before issuing the certificate. Overall, HTTPS protects user privacy and prevents eavesdropping or data tampering online. This protocol should be baked into your brain at this point in your studies. So, all right, we've got the file transfer protocol. FTP, or file transfer protocol, is used to upload and download files between a client and a remote server. It operates over TCP using port 21 for control commands and port 20 for data transfer. So that's two ports for that, your 20 and your 21. You can see that listed on the diagram here. FTP supports two connection modes, active and passive. In active mode, the client tells the server which port to connect to, and the server initiates the data connection. In passive mode, which you see in the diagram here, the server provides a random high number port, and the client initiates both control and data connections. So you can see the difference in the port flow in these diagrams. Passive mode helps clients connect through firewalls and NAT devices more easily. Active mode can cause problems with firewall configurations as the server initiates the inbound connection. All right, so the server initiating the connection, and the firewall would have to be specifically configured for that, and possibly would feel a little vulnerable and may even violate company policy. So you can see why passive might be the better way to go. A firewall may drop idle control connections during file transfers if it's not configured to allow FTP traffic. So FTP remains widely used for administrative file management, especially for server maintenance and appliance configuration. So even though it's highly used, it's mainly used on the back end by tech personnel. It's not a common user protocol. And in conjunction with FTP, I'm going to speak a little bit about TFTP, the Trivial File Transfer Protocol, TFTP. It's a simplified file transfer protocol running over a UDP port 69. Unlike FTP, TFTP is connectionless, meaning it does not guarantee delivery or reliability, hence the UDP. It only supports basic operations, reading, get, and writing put files. So you can only do get and put. TFTP does not support directory navigation, file deletion, or authentication. So basically it's just getting and putting. It's primarily used by network devices such as routers, switches, and printers. Common uses include downloading configuration files and firmware updates to devices. It can also serve as a backup and restore method for configuration data. Because it lacks security mechanisms, TFTP should only be used in trusted or isolated networks. Modern systems often replace TFTP with more secure protocols such as SFTP or HTTPS-based transfers. TFTP remains useful in legacy or embedded environments where simplicity and low overhead are essential. You may find it used for TFTP at some point. Just make sure that it's in a very controlled network where you're not vulnerable to eavesdropping. All right, so the Secure File Transfer Protocol, or SFTP, all right? SFTP enhances FTP by encrypting both authentication and data transfers. SFTP operates over TCP port 22 using the Secure Shell Protocol, SSH. It creates a secure encrypted link between the client and server before any file transfer begins. Standard FTP commands and data can be safely transmitted over this channel. SFTP requires an SSH server that supports SFTP and an SFTP compatible client. Another secure method for FTP is FTP over SSL or TLS, right? So that is FTPS. So in today's world, FTP over TLS. So you've got your explicit TLS, has its own acronym. FTPES uses the auth TLS command to upgrade a standard connection on port 21 to a secure one. And then you got your implicit TLS, your FTPS. It establishes an encrypted connection from the start over TCP port 990. The prot command, PROT, in FTPES allows optional encryption of the data transfer connection. Because FTPS can be difficult to configure with firewalls, FTPES is generally preferred for secure file transfers. All right, so if you call on to all that, that's a lot of acronyms and explanation, and it's in the instructor notes should you want to download these slides. All right, moving into the server message block, SMB, right? So file and print services let network users share access to files, folders, and printers. I mean, it's one of the big values of working on a network. Right? On Windows networks, these services use the server message block protocol. SMB enables a host to share directories and printers with other computers on the network. Samba software provides SMB support on Linux and Unix systems, allowing interoperability with Windows. So that's important to know. Samba lets Windows clients access Linux shares and vice versa. Originally, SMB operated over NetBIOS using TCP port 139. You see that's listed here on your slide as legacy networks. Modern SMB implementations run directly on TCP port 445 without NetBIOS. SMB network should be restricted to local networks and blocked at the firewall perimeter. SMB version 3.0 and later support message encryption for secure file transferring, secure file sharing, and encryption can be applied at the server or per share level. SMB1 is deprecated due to serious security vulnerabilities and is disabled by default in current Windows systems. So we're up to SMB version 3 at this point, at the time this video is recorded. So, moving on. All right, so we're about halfway through 31 slide deck here. So if you want to pause it here and grab yourself a little break, not a bad idea. I'm moving on. All right, so all right, picking back up here, if you notice a little blip in the video, it's because I paused and took a little break myself just because it seemed like the right time. So maybe you did the same thing. All right, so here we are talking about NAS, network attached storage. NAS is an appliance. It's a dedicated device used for file sharing and storage. Typically runs a custom Linux-based operating system and is managed through a web interface. NAS devices are accessed via an IP address or domain name using protocols like SMB or FTP, protocols that we just discussed. Most NAS systems support RAID, which protects data by distributing it across multiple disks. That's RAID, R-A-I-D, an acronym. A downside is that NAS shares network bandwidth with other traffic, which can slow performance. So you're using, unlike a SAN, which is a separate infrastructure, NAS is on the same network infrastructure. On well-provisioned networks, NAS provides a simple and efficient way to add and share storage. Right, so you can kind of see here in the diagram the difference between the server and the NAS, just in the architectural way it's represented here. It truly is just a place for files to be stored. It's not doing any applications or anything like that. So just a storage device. All right, so we have our database services. So we have our various relational database management systems and their port numbers listed here. Let's get into some of this here. So as you know, a database organizes and provides information that can be accessed and updated using a query language. There are two main types of relational databases, relational and your NoSQLs. Okay, NoSQLs. NoSQL. Relational databases store data in tables with rows, records, and columns or fields. Relations between tables are established using key fields that uniquely identify records. Relational databases are operated using structured query language, or SQL. SQL commands include select to retrieve data and update to modify data. Relational database management systems are your RDBMS, which is an acronym in itself that I don't necessarily see that in wide use, but they implement SQL and offer management tools and GUIs. Relational database management systems allow remote client access and replication to synchronize data across servers. Common RDMS platforms and their default ports include, like you see listed here, you got your Oracle SQL, TCP 1521, our Microsoft SQL Server, TCP 1433, MySQL or / your MariaDB, TCP 3306, and your PostGRE SQL, TCP 5432. These default ports are insecure by default, but TLS encryption can be enabled for secure communication. So there we are, pulling some of these things back together. We talked about TLS earlier as a way to secure unsecure protocols. There's another example of that. Servers and clients can be configured to require encryption and validate certificates. NoSQL databases store data in flexible formats like key value pairs or wide columns. NoSQL databases are usually accessed through APIs over HTTPS instead of SQL. Popular NoSQL platforms include MongoDB, Amazon DynamicDB, and CouchDB. Many modern relational database management system platforms also support NoSQL features alongside traditional SQL functionality. All right, let's get into 7.3 here, email and voice services. So this speaks to our Network+ exam objective, 1.4. All right, some services here. We're going to get into these in a deep and meaningful way. Right? We have our Simple Mail Transfer Protocol, or SMTP. All right, SMTP defines how email is sent between systems. The sender's SMTP server uses DNS to find the recipient's server through MX or A/A records. SMTP does not store emails permanently. It retries delivery for a limited time before sending a non-delivery report, or an NDR. NDR includes error codes explaining why delivery failed. SMTP communications can be secured with TLS encryption. There's TLS again. Start TLS upgrades, and that's a protocol, all one word. Start TLS, so that's START TLS. Upgrades an existing connection to TLS, and then implicit TLS begins encryption before any SMTP commands. So this is the preferred way now. The start TLS is still common, but it's people are slowly migrating to the more preferred implicit TLS. Port 25 is used for server-to-server message relay command and can use start TLS if supported. Port 465 supports SMTP submission with implicit TLS. And port 587 is used for SMTP submission with explicit TLS via start TLS, which we talked about as becoming still common, but less preferred. All right, so our Simple Mail Transfer Protocol. Let's see, is there something else here that I think I spoke to everything here, but let's just notice some of the stuff that I mentioned in the port numbers. So these are the protocols spelled out here on the screen for you, so you can kind of see how the acronyms are worked out, and then the port numbers that we spoke to already, port 25, 465, and 587. All right, so we have our Internet Message Access Protocol, or IMAP. All right, so SMTP is useful only to deliver mail to hosts that are permanently available. When a message is received by an SMTP server, it delivers the message to a mailbox server. This could be a separate machine or a separate process running on the same server. A mailbox access protocol allows the user's client email software to operate the mailbox. So IMAP is the most, which we're talking about here, is the most widely used email retrieval protocol. It allows multiple clients to access the same mailbox at the same time. Users can organize their messages, create folders, and manage deletions directly on the server. IMAP does typically uses TCP 143, which is insecure by default. Secure IMAP uses TLS encryption over TCP port 993, as you see here identified. Just a note here, in a Windows environment, the proprietary Messaging Application Programming Interface, or MAPI, M-A-P-I, protocol is typically used to access Microsoft Exchange mailboxes. So MAPI uses, for an additional note here, uses HTTPS as a secure transport protocol. So just to speak to our alternative protocol on this slide there. All right, voice and video services, making progress here. Slide 22 of 31 now, so we have hope. We're going to get there. Web conferencing and video teleconferencing are standard tools for business and social communication. Many organizations are transitioning from traditional voice systems to IP-based communication technologies. They say many are transitioning. Many have transitioned as well. I mean, it's becoming the norm, right? Legacy voice systems relied on the public switch telephone network, or your PSTN, and analog plain old telephone service, or our POTS lines. POTS connections provided one or two analog lines, allowing only a single call per line. Business historically used digital trunk lines or time division multiplexing circuits to handle multiple voice and data channels. A private branch exchange, or a PBX, serves as an internal switchboard for routing and managing voice calls within an organization. Traditional PBXs were TDM-based, connecting to carriers via digital trunk lines and supporting features like voicemail and call waiting. Modern PBXs are often VoIP-enabled, transmitting voice and data over Ethernet using Internet Protocol. VoIP PBXs can be implemented as software, and examples would be like your 3CX or your Asterisk, or as hardware integrated into routers, such as your Cisco Unified Communications Manager. VoIP PBXs reside at the network edge, connecting through firewalls and enabling internal IP calls as well as external calls to landline and mobile networks. All right, VoIP protocols here. Got a lot to say about this. So voice and video services demand extremely low latency, measured in milliseconds, to maintain high quality communication. Delays in response time can lead to poor audio or video performance. Real-time communications can be one-way, like media streaming, or two-way, like VoIP or VTC, which would be, video communications. Protocols for real-time services support three main functions: session control, data transport, and quality of service. I'll bring in our acronym QoS, capital Q, O, capital S. Session control manages setup, negotiation, maintenance, and termination of communication sessions. Data transport is responsible for delivering the actual voice or video content between the endpoints. And QoS integration ensures reliable performance by reducing issues such as packet loss, delay, and jitter. Session Initiation Protocol, or SIP, is the most common session control protocol used for VoIP and conferencing. And I got some details here on SIP. I'll just give you, SIP typically operates on TCP/UDP port 5060, which is unsecured, or 5061 if it's secured with TLS.
Real-time transport protocol, or RTP, carries the actual audio-video streams using UDP for minimal latency. And then we've got RTP control protocol, which is the RTCP, monitors connections quality and provides feedback to adjust codecs or QoS parameters dynamically. And since I introduced the term codec into this presentation here, I thought I'd define that for you. So a codec is a coder decoder. That's what the acronym means, or the word means. CODEC is for coder decoder. It compresses and decompresses digital audio or video data to enable efficient transmission, storage, and playback. It reduces the bandwidth while maintaining quality, and there are various different codec standards or protocols, including H.264, H.265, so on, and etc. All right, VoIP phones. All right, a VoIP or a SIP endpoint can be software on a computer or a smartphone or a dedicated hardware handset. VLAN tagging separates SIP control and RTP media traffic from regular data traffic for better performance and management. In a typical setup, the handset connects to the wall port and the PC connects through the handset. VLAN IDs distinguish between voice and data traffic. I believe I've sort of described this to you guys in class before. Power over Ethernet, or PoE, allows handsets to receive power through the network cable, eliminating separate power cords or batteries. Some VoIP handsets are wireless, operating over 802.11 Wi-Fi networks. Secure SIP, or SIPs, as it might be, use digital certificates and TLS encryption to authenticate endpoints and protect communications. The SIPs connections also generate a master key for encrypting voice and control data. After installation, it's important to test call connectivity and quality to ensure configuration. So once you have a SIP or a VoIP connection set up, you should always test it. Service providers often provide test numbers or echo tests to verify sound clarity and network performance. So if you wanted to test your end devices, your VoIP phones, with your carrier, there's generally ways to do that using test numbers. 7.4, disaster recovery and high availability. All right, round the corner, round the bases. I guess we're on third base at this point. Addressing our exam objectives 1.2, 2.1, and 3.3. All right, we're going to go over these items here. Disaster recovery concepts, recovery metrics, recovery sites, and fault tolerance and redundancy. Disaster recovery planning relies on measurable metrics that define service reliability and recovery time after disruption. Availability measures the percentage of time a system is online within a given period of time, typically a year. This inverse is downtime. The inverse is downtime, or the time the system is unavailable. High availability is expressed as percentages like 99%, which is 2 nines, or up to 99.9999%, which is 6 nines. I at one time worked in a 5-9 environment. That was our goal at all times. All right, took a little blip there. I had a phone call, sorry, but we're moving on here. So 99.9, so our 3.9 availability equals to about 8 hours and 45 minutes of downtime per year, while the 6 nines is only 32 seconds of downtime. So to get to where you're in a 6-9 situation is quite expensive, and all the different redundancy and recovery that you need. but it is possible.
All right, moving through this here. So continuous availability refers to systems with virtually no downtime. So that would be in your life-critical applications like your medical networks, air traffic control, autonomous vehicles even. And then a concept here, let's see, maximum tolerable downtime, or your MTD, defines the total allowable time to restore operations before unacceptable consequences occur. And then you've got your recovery time objective. It specifies how long an individual system can remain offline after a disaster before recovery begins. Our work recovery time is the additional time needed after system recovery to reintegrate data, verify functionality, and resume normal business operations. So there's a calculation there. Your RTO plus your WRT should be less than or equal to your MTD, your maximum tolerable downtime. All right, so disaster recovery site. So after speaking about metrics, let's talk about site. So disaster recovery plans outline the exact steps to restore systems or sites to operational status. After a disruption such as a power loss or a hardware failure or some kind of natural or human-made disaster. Redundant devices, spare parts, and backup network links enable quick recovery by swapping in functional components when failures occur. Many enterprises maintain alternate processing sites to ensure services can fail over automatically if the primary site becomes unavailable. So you got different types of sites. You've got your hot site, which can assume operations almost immediately since they are fully equipped and synchronized with live data. Warm sites, they're pre-configured systems but require current data restoration before becoming operational. Then a cold site, they're basically just facilities without equipment requiring full setup before recovery can begin. So depending on the criticality of your system, one of these is probably the one that's most beneficial for your type of organization. And then cloud-based disaster recovery offers cost-effective, geographically redundant solutions, reducing downtime and dependency on physical backup sites. So speaking to our last bullet here, fault tolerance and redundancy, switching services to a disaster recovery site should be rare. Resilient networks should handle routine faults internally. A fault is any event causing a service outage or a degradation. All right, so there's lots of fault tolerance information. Here's what I'm going to give you guys on this. The video is getting longer than I really want it to be. Still got a few things to wrap up. So for fault tolerance and redundancy, what I want you to do is, you've already had the learning in the modules, but if you want more information on that, download the slides in Module 7. Slide 26 has the notes. So we'll get that done. Okay, some of the items that allow for the fault tolerances. All right, so we've got our load balancers. So a load balancer, as you see in the diagram here, distributes client requests across multiple servers in a farm or pool, improving performance, fault tolerance, and scalability. It can be implemented as a hardware appliance or software-based service
positioned in front of server networks to manage incoming traffic from clients on the internet. Clients connect to a virtual server address, which you see here in the next to the number 1 in the example here. It can be implemented as a hardware appliance or software-based, positioned in front of the server networks to manage incoming traffic from clients or the internet. Clients connect to the virtual server address, which represent the balanced service instead of individual servers. Common use cases for a virtual server include web servers, front-end email servers, and media or conferencing servers. Load balancers enhance availability and mitigate DDoS attacks by managing request distribution efficiently. Layer 4 load balancers, or our transport level, make routing decisions using IP addresses and TCP/UDP ports. Layer 7 load balancers, or your application level, they use advanced logic based on data like URLs, media types, or session persistence. Modern load balancers often function as multi-layer switches capable of operating across layers 3, 4, and 7 of the OSI model. All right, so we have our high availability clusters. All right, you see the diagram here. So a high availability cluster, or an HA cluster, allows multiple redundant processing nodes to share data and connections. To clients, the server appears as a single unified server. If one node fails, the workload automatically fails over to a functioning node. A virtual IP is used to represent the cluster as one service. The VIP or the VIP is shared between appliances, known as a floating or a shared address. Each cluster node also has its own private or its real IP address for internal communications. Redundancy protocols like CARP, the Common Address Redundancy Protocol, manage which node owns the VIP. These protocols use heartbeat signals to detect node failure and trigger failover. The typical topology includes clients connecting to a VIP that forward to load balancers and back-end servers. Load balancers are often configured as active-passive pairs for redundancy. The same architecture supports routers and firewalls for high availability and load sharing. In active-passive clustering, one node runs services while another stands by. Active-passive setups maintain performance, but can increase unused hardware cost. In active clustering, all nodes handle connections simultaneously. Active designs maximize capacity, but can experience degraded performance during failover. So we've got our first hop redundancy here. So let's talk about this. There is a Cisco proprietary version of this, and then there is a standard version of this. Let's talk about both. This is our diagram here. I tried to make it bigger for us. Sorry guys, I got distracted there. Moving on. All right, so let's see here. So first, hop redundancy. All right, so mesh networks can reroute around failures, but end systems usually rely on a single default gateway. Configuring multiple default gateways on a host is complex and rarely practical. To improve gateway fault tolerance, protocols like HSRP and VRRP were developed. So HSRP stands for the Hot Standby Routing Protocol. And this diagram you see here, this could be configured with either of these protocols. HSRP is a Cisco proprietary redundancy protocol. Multiple routers share one virtual IP and MAC address as a common gateway. Each router also keeps its own physical IP and MAC address. The routers form a standby group communicating via IP multicast. So an active router handles all traffic for the virtual IP. A standby router monitors the active one and takes over on failure. Router roles are determined by administrator set priorities. So when the active router fails, a new standby is chosen automatically. Cisco's GLBP extends this concept to provide active when load balancing. So, and then you got your virtual router redundancy protocol, or your VRRP. It's an open standard alternative, so it can be used on non-Cisco devices, or is employed that way. VRRP uses master and backup routers instead of active standby terminology. And VRRP allows all backups to monitor the master and support using only the virtual IP, saving address space. Moving on here, fault tolerance and redundancy. This is actually just a slide for various acronyms for KPIs and redundancy examples. I'm not going to read all of these to you, so if you want to read through these, pause for a second and pause the video and read them. Moving on. All right, in this module, we went through these items. It was a lot. I mean, for it to just be summarized at 4 bullet points, it's a lot. But let's wrap up with this last bullet here. It is critical to anticipate and mitigate disaster risk through business continuity plans and address issues with disaster recovery plans. All right, so thanks for listening today. I believe that's really all I really wanted to talk about with you guys today. Keep working on toward your goals with this course and for your learning. And take the hint that I gave you in the beginning of the video and start working on the practice exams sooner rather than later. All right, thanks. Bye.